Hello everyone, I am Anandavalli. Welcome back to Guidance Education channel. In this video, we are continuing solving problems on capacitors in combination. This is part 2 under that series. In this video, we will discuss problems related to adjacent plate capacitors. We are continuing class 12 physics, chapter 2, electrostatic potential and capacitance. This is the representation of the adjacent plate capacitor showing its combination. We have to find the effective capacitance between A and B. This is point A and this is point B. This combination looks complicated. We have to simplify that. We will first number these plates 1, 2, 3 and 4. A capacitor has two plates only. Let us mark how many capacitors are possible here. Between 1 and 2, there is capacitor C1. Between 2 and 3, there is capacitor C2. And between plates 3 and 4, there is capacitor C3. Now we have to show the circuit. For that, we will just mark the points A and B. Which of the plates are connected to A and B? We will mark that. Plate 1 and 3 is connected to A. Which are the plates connected to B? It is 2 and 4. From the diagram, we see capacitor C1 is between 1 and 2. We will make a representation of that separately. Between plates 2 and 3, there is capacitor C2. Plate 2 is connected to B and 3 is connected to A. So, we will show the capacitor C2 between 2 and 3. Now, C3 is between 3 and 4. 3 is connected to A and 4 is connected to B. So, you can connect capacitor C3 between 3 and 4. Let us make the diagram more perfect. This is point A and this is capacitor C1. It is connected to the point B. This is capacitor C3. And finally you have capacitor C2. These three are connected in parallel. You can understand that from the diagram. What is the effective capacitance for capacitors combined in parallel connection? It is C1 plus C2 plus C3. Let us suppose the capacitance of each capacitor is equal to C. Then capacitance effective equal to Cp becomes C plus C plus C, that is equal to 3C. 3C is the effective capacitance between A and B in the given circuit. Now, next problem. Look at this arrangement. This is slightly different from the previous one. We have to find the effective capacitance between A and B. Just as we did in the previous case, we will number this as 1, 2, 3, 4, 5, 6 and 7 plates. We will also mark A and B. Capacitor C1 is between plate number 1 and 2. Capacitor 2 between 2 and 3. Capacitor 3 between 3 and 4. Capacitor 4 between 4 and 5. Capacitor 5 between 5 and 6. And capacitor 6 between 6 and 7. First we have to mark point A and B separately. Which are the plates connected to A and B? In the diagram, we find 2 and 4 are connected to A. Similarly, 3 and 6 are connected to point B. Plates 1 and 2 correspond to capacitor C1. 2 is connected to A, but 1 is not connected anywhere. So, we will show capacitor C1. One plate is connected to A, the other plate is just shown connected to a point in the middle. Capacitor C2 is between 3 and 2. So we will represent it between 2 and 3, that is connected to A and B. Capacitor C3 is between 3 and 4. 3 is connected to B and 4 is connected to A. So C3 can be connected between 3 and 4, that is between B and A. This is capacitor C3. Now C4 is made up of 4 and 5, plates 4 and 5. 4 is represented there, 5 is not connected anywhere. So just as we did for C1, here we will connect plate 4 to point A and connect the other plate to a point which is left in the middle, marked as 5. Capacitor 5 is between 5 and 6. You have 5 at this point and 6 is connected to B. So capacitor 5 is between point 5 and point B. We have one more capacitor C6 between 6 and 7. 6 is connected to B, but 7 is not connected anywhere. So we will represent it like this and connect the capacitor to B because plate 6 is connected to B. This is capacitor C4, this is capacitor C5 and this is capacitor C6. In the case of C6 and C1, the connection is not complete. That is, the circuit is not complete. Therefore, those two capacitors cannot be charged. So, they can be cancelled. We will redraw the circuit. This is point A. C2 is connected to point B. Then you have C3, then C4 and C5. That's all. Now the circuit is simple. These are the 2 points A and B. Let us assume the capacitance of the capacitors in the circuit is C. C4 and C5 are in series. Effective capacitance of C4 and C5 will be equal to C upon 2. Instead of C4 and C5, we can now substitute in the circuit a capacitor with effective capacitance C by 2. Then all the capacitors, that is all the 3 capacitors, will be in parallel. Then the effective capacitance Cp becomes C plus C by 2. This can then be written as 2C plus 2C plus C upon 2, which is equal to 5C upon 2. So that is the effective capacitance for this whole circuit between A and B. I hope it is quite clear. We will see one last problem under part 2. Look at the combination. There are 4 capacitors C1, C2, C3 and C4. A wire is connected from this point up to this point and another one from this point to this point. Let us mark this point A and the other point X. The potential at point A and at this point where the wire is connected will be the same because in between there is no other element. So we will mark this point also as A. Between these 2 points in the wire connected there is no obstruction. Therefore, the potential at this point also will be A only. These 2 points marked A have the same potential. As you move from point A along this line to the next point, you find a capacitor C1 in between. So the potential at this point will be different. We will mark it as B. From this point up to this point along this path, there is no interruption. There is no element connected there. So at that point also, the potential will be B. As we move from this point, you find there is a capacitor C4. So the potential at X is different from that of B. In the question, you are asked to find the effective capacitance in the circuit. Now that you have point A and B, it becomes very easy. Connect capacitor C1 between A and B. Between B and A, there is capacitor C2. So, mark that in the diagram. Capacitor C2 is connected. Now, there is one more capacitor between A and B, that is C3. Okay, we will connect that. Now, C3 is connected. C4 is beyond B, that is between B and X. So, C4 is represented like this. Capacitors C1, C2 and C3, as you can see, are in parallel. So, we can easily find out the effective capacitance. We assume the capacitance of each capacitor as C. So, Cp is equal to C plus C plus C equal to 3C. Effective capacitance in the case of parallel combination is the sum of capacitance of all the capacitors. Suppose that C is equal to 5 microfarad. Then 3C becomes equal to 15 microfarad. Now let us substitute this effective capacitor in the diagram. Capacitor 1, 2, 3 can be represented by a single capacitor having effective capacitance equal to 15 microfarad. And then show capacitor 4. The capacitance of C4 is already assumed as 5 microfarad. These two capacitors are between points A and X. Please refer the first diagram given in the problem. They are in series. So we can easily calculate now the effective capacitance. The effective capacitance will be equal to 1 upon Cs is equal to 1 upon 15 plus 1 upon 5. So 1 by Cs, that is in series, will be equal to 20 upon 75. So when we take it as Cs, we just reverse it. So it becomes 75 upon 20 equal to 15 upon 4. On simplification, this becomes 3.5 microfarad. So we have solved that question. Effective capacitance is equal to 3.5 microfarad. I hope this video was of great use to you. If you think it is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not subscribed my channel, do subscribe it now. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.